it just my imagination, or does that fan keep increasing speed or something? Maybe it's my imagination. Okay, let me see if I can go to that's now. Let's do this. Okay. All right, goose. There you go. I don't know what else to do. And while I'm there, which I do not know which week it is. Here, let's see. Go to the very bottom after it comes up. Oh, that's perfect. So, what do I do? Do I just dump this? I just dump it. Homework 8. Then I'll do open it, show in a folder, and then open it. Alright, so I'll just monkey around with these things for the next couple days. And I don't know if it's out of section 16, 1, 2, or 3, or 4. I know these problems are down in here, but I'll just do them both with instant centers and the other, and then I'll get to the acceleration when the problem tells me I should. So the first one says determine the angular velocity. Is it showing up on the screen? What is that big thing like? And the other thing, why is it not full screen? And I can't get rid of that funny bar at the bottom. There's something in here about how to hide that. Configuration, microphone, copy, alignment, adjustment, focus, view option, full screen. Ah, there we go. Yeah. And it seems like it's at an angle. I don't know. Maybe the camera is tilted up here. I can't tell. And then the other thing is the light. Is that a little bit better? Like that. The light comes in from here, from behind me. Of course, I'm blocking it now. You can get with more comfortable chairs in here. Okay, so you got two choices, and one is, I guess I can't zoom to the right, can I? Or I can zoom in, and then I can slide to the right. One is using instant center. Now, I'm going to use his little thing here. He's showing these little streaks here. And I'm going to say, because of his streaks, I'm going to assume that it's going this way. And then, okay, I don't know if he gave that. Let's see, what did he give us? Oh, okay. It is moving. I'm going to change that to 1. Well, this is everything's in inches, so 12 inches per second. Now, he's shown this going this way, but I like to always put down an X and a Y. If you cross the I vector and the J vector, I cross J gives you K, which means your thumb is pointing at you, so a rotation this way mathematically is positive. And then what you get is he's got that going the same way as this. So if it is going this way and we don't know what it is, AB, we don't know what it is, we can just use it as a symbol. If that's the case, we know this value here is going exactly perpendicular to a line from A towards B and on out. Then the key is, if we start thinking, if we erase this link from our memory and we have a link B and C, so if we're only focused on this link now, then its instant center would be this. Okay, draw a line perpendicular to the velocity direction that we know of, and then draw a line perpendicular. This doesn't look exactly 90 degrees. Oops. Let me take my hat off. It's bumping against it. So this one, let me try it again. That looks a little bit better. But we know that line is actually that through here. And so the instant center becomes a spot right here. Instant center of BC. Now this is the location that's the instant center of AB. So now we just got to find this distance and this distance. We can use our instant centers to figure things out. So what we'll do is I'll zoom in close enough so I can start using some of the information here to find these two distances. And so I guess I'll label this one D1 and D2. And I think I'm far enough away from the drawing I can start monkeying with things here. If I'm looking for the angle between here and here, and I happen to think to myself the angle between here and here, this one is 45 because this one is perpendicular to that one. So that leaves 45 from this one, 45 from here, and 30 from there, plus 45 plus 30 plus whatever this one is, got to equal 180. And you know what? I did not start octave, and I'm just gonna give me a second. So 180 minus 45 minus 30 should give me 60. So turns out, and there are other ways you could figure this out too. One is this is 90 degree to here, and so it has to be 60 based upon 30 plus something's got to be equal to 90. There's 2 or 3 ways to do that. I did it the long way. So this becomes 60. So now you've got a triangle. Do I have any other? I got a white line here. So I got a triangle that goes from here to here, and then across. This is a distance 4. I got this thing, 60. I got 105. You know what? I think I'm gonna do this. I'm gonna try to move it up and redraw it as best I can. So here's what I got. I got, let's see, 60. This is 115, I think. Isn't that right? 6. No. 105. So this angle and this go together to give me 105. This angle, since this is 30, and this line is parallel to that line, that's got to be 30. That leaves me with, okay, wait. Okay, 180 minus 105 minus another 30 gets me back to 45. I should have known that. Okay. The reason I should have known that is this is 45, and that, since this line right here and that line are parallel, that should have been, I should have known that. Then I got a length of 4. So now I want to know D1, and I want to know D2. So this is one of those things where it's like the signs. D1 over the sine of the opposing thing right there of 105 equals to D2 over the sine of its opposing angle, which is 30, equal to 4, and the sine of its opposing angle. So now I can come up with D1 equaling to, and I'm going to have to, 4. Okay, so I'll write it down first. How about sine, oops, that's supposed to be 105. 105 times 4 over sine 45 gets me a number. 4 times the sine in degrees of 105 divided by the sine in degrees of 45 gets me 5.4641. Now if I want to do D2, I just do the sine of 30. So I'm just taking this, multiply it times the other side there. What happened there? That's 4 over the sine 45. That'll give me, all I gotta do is replace that 105 with 45. I'm sorry, 30. $2.8284. So now what I've got, I'm going to redraw it again. This time I'm going to redraw it a little bit bigger. this time, I'm doing a terrible job of drawing it. D1 is 5.4641, and this is 2.8284, and this is 4. And now this thing appears as though it's rotating about that. And on the tip, this is 12, and this is something. So if you have a triangle, imagine you have a triangle, which is this whole big piece of green metal, or aluminum, or whatever, wood or whatever, that is pinned right here at the instant center, and it's rotating that way, then omega times, or say, velocity is equal to omega r. The velocity in this case will be that, the r will be that, and the omega will be right here. So what I'll do is write this down here. 5.4641 is equal to 12. I rearranged it because the 12 is the velocity, so technically, if you want it exactly, you get 12 over there. And this would be the omega BC, sorry. So this is, you have to ignore the fact that this link exists for a minute. And now you're just focused on this link, which is the link from here, here, and it's B here, and C here. So omega BC, omega BC is going to be equal to 12 divided by 5.4641, if I copied that down correctly. I get 2.1962. I don't remember what he asked. Oh, he wants to know the velocity of link AB, which is this link. So now, you can work your way to that. I really need to know the velocity at B. So the velocity at B is equal to omega VC times the distance from location B to the instant center, which is this. So in other words, you're wanting to know this velocity right here. And so it's rotating at that point, but it's 2.8284 inches away. So the velocity of B is equal to now this 2.1962 times the distance between those is 2.8284. So in other words, that, and this happens to be the same for the whole length. So now I'll get the velocity of B, 2.2. Okay, so I already have that number in the thing here. I can do it arrow up and then multiply times 2.8284. I think I got it. 6.2116. Now, I haven't completely answered the question, but I do know the velocity of B, which is common to both this link and the other one. So point B sits on this link, it also sits here. So now if I imagine that I'm only focused on the link AB, don't know how to do this. As far I've got the drawing so messed up, so to speak, but let me see if I can do it this way. I'll just try to mimic it the best I can. So you got this spot A, location A, this right here, and it's coming down here, and this velocity is 6.2116 because it's on BC and it's on BA. It's on both links. And if I zoom back in on it, I can see that link is 5 inches long. So since the point B is sitting on both, this is 5. Now, we're looking at the omega AB, this is B now. B sits on both links, so it has a common velocity. Then velocity is equal to omega AB times the length, or the distance from A to that B, which in this case was just equal to 5, and this velocity is still that, so you get 6.2116 is equal to omega AB times 5, where omega AB equals to, I don't think I do have it still in there. There it is. Move up. Divided by 5. 1.2423. And so that's, we don't have a lot of room, but that's the answer. So let's find it a different way. And unfortunately, I've hacked up this thing like crazy, so that's one way to do it. I did it instant center here. But what I'm going to do now, I don't know, can I do this in here? In other words, can I select the whole thing and maybe shrink it, and then here, shrink it down. Oh, it does work. It looks funny looking. Get it out of the way. Okay, now what I'll do is copy the whole thing, and then I'm going to go back over here. Okay. I don't know if that'll be. So I'll just drop it like right there. And we'll do it a different way. And, oh, that was part of the copy. Yeah. Okay, so this time, what we're going to do is go down the links. In other words, velocity, I guess I didn't get the B right there. Velocity of B is equal to velocity of B relative to A plus velocity of A. Now, this can be written because there is a rigid link AB. I can now write velocity of C is equal to velocity of C relative to B plus velocity of B. And this is because rigid link is a rigid link between B and C. What I can't do, this seems weird, but I can't, I can write the equation, but you can't use it because there is no rigid link AC. Here's A and here's C. There's not a link there. So this, you can write an equation all you want, you can't use it. So this is useless. That doesn't get you anywhere. So what I can do is run down the links. And that's what I'll do. I'll go ahead and run down the links the way I've got them in here. So I'll start with B, for example. Velocity of B is equal to, so I'm basically copying this down. So I'm going to go ahead and do the next step. And maybe I'll go back and reference it. So if I go back and reference it, I think I can find that page relatively quickly. I think. Just shrink back. There's a section on instant center right previous to that is right in. I'm trying to find where he actually wrote these. These are the examples. Okay. So here's what we're doing. Give it a second. Okay. All right. So what we're doing, let me get this. It's moving slow. So what this term is the velocity of B as if you were sitting on A. Now I write these terms in front, so I'll always just, it's my nature to write the equation like this. Mostly because this is where most of the work is done. And this is just hanging. I just hang it and I carry it along. So I try to focus not on that, but focus on this, which is this term right here. So it's omega of the link times R. So now, let me go back. So it's the omega of this link, because I'm on AB, cross R. It matches this plus, so the subscripts here match the subscript there, and then I just carry the VA. The reason I carry it along is just because it's there, but A is pinned, so in this particular case, this is nothing. So what I end up with is velocity of B equaling to I, J, and K, and I'm making them a little longer. 0, 0, and omega AB. Now, the reason I list it that way is because in this one, the sign convention is relatively important. So that's a plus omega that rotates counterclockwise. So I assume it to be plus. It just so happens he's drawing it that way. But if he drew it the other way, I would erase it and draw it in a positive way, so I can list this as a positive number. So now I'm shooting for what is that? And that is a vector that starts at A. Starts at A here, heads down here to B. Turns out he's 45, or he's 45 degrees. So that means that's going to be 5 over square root of 2 in the positive direction, positive x. And then 5 over square root of 2 negative going down right here. So with that, I didn't do a good job of writing it here. Let me write it here. R VA is equal to, here I'll just do this. And then what I'll do is I'll adjust this, because for some reason it's written lower. Hello. There. So now I can just copy these entries down into the lower row here. And so what I got is 5 over square root of 2. I'm going to get a minus 5 over square root of 2. and then I get a nothing because it's not coming out of the page, it's staying in the page. So, and I could write 0 here because that's 0, or I could just leave it off because it's not, it's 0, so it's nothing there. So, you go do the cofactor expansion, you get this, you ace this out and this out, and then you look at copying this matrix down. So you get omega AB times 5 over square root of 2 and 0. And then you do minus because you're moving to the second one. And then what you do is you ace it out and this one out. And then you copy this down here. 0, omega AB, 5 over square root of 2, nothing. And then you do the useless one, and you take this one out and this one out, you take that and copy it down. But what you find out is there's never any, for this planar stuff, there's never any component there because this gets you 0 and that'll get you 0. So if you want to write it out, you get 0 and then you get minus whatever that is, which is a minus already. So it's 5 over square root of 2 omega AB I plus, and then a minus component there, which is minus, but it's already a minus, 5 J. And so if you stop for a moment, okay, this is true, this is velocity B, but technically this is the velocity of B as if you were fixed on A. Well, it turns out A is already fixed. And so if you go look at it, if this truly is spinning in the positive direction, then you're going to have a velocity that's going to have a positive X component and a positive Y component. So is that what I got? I do have a positive and I do have a positive. So at least I got the right direction. And then the next thing is the dot product. In other words, this times that term, and then this times that term. If you stare at it for a minute, you'll realize they exactly give you 0. And that goes back to the law of mathematics, which says you have a vector, and you cross it with another, you'll get a C vector, you have an A, and any sort of B, the C that comes from it is going to be perpendicular both to A and to B. So that means you dot the result with any one of those vectors, and you're going to get a 0. So this is a check. So this stuff right here can be used as a check to make sure along the way that at least at this point, if you messed up, you messed up uniformly. So, okay, go away. Why is it not erasing? Okay. So what I'll do is I'll just hold on to that for a second. I'm going to pause. And then I need to go in and work on this one. You know what? I never even said. Give me a second. Uh-oh. I love the thing that's not working. Oh, it's working. I usually check, I just forgot. Okay, so the next phase is to work on this component. And if you head off and work on it, you're just becoming regimented, so to speak. Omega AC, because now you're on link when you're working on this. you're on link mistake of BC. So you're existing now on BC. So effectively, you got two different links and two different omegas. Omega BC, omega AB, and they may not be necessarily equal. And from our previous thing, they weren't equal, if I remember right. One was, so one of them was this, and then the other one was this. So they were not equal. One was 2.19 and one was 1.24. He only wanted to know that one. But to find that one, you're going to have to find the other one. So let me go back. So now I'm over here, across R, C to B, plus velocity B. This time, believe it or not, I do know that one. So instead of inserting it right off, I'm going to avoid inserting it until I work some stuff down, and then I'll insert it down in here. So what I'll do is carry it as a variable. But in the meantime, and I got velocity of C, I, J, K. I do not know omega BC, so therefore I'm going to assume it to be positive, as always. And then I'm going to draw a vector that originates from B and points to C. And so, in essence, what I'll do, kind of move this down a little bit. And above it, I'll do RC to B, and then I'll go over to the drawing, and I'll say I'm drawing a vector that looks like this. This is a vector, C, originating from B. Now, did I do it that way? Yeah, so here's my vector. So it looks like it's equal to 4. I got a component going that way, cosine 30, I, and then I got a component going up, plus 4 sine of 30, J. So I got that. So for me, I'll be a little lazy and say 4 cosine 30, that's my shorthand for that, and then 4 sine of 30, and then nothing. I go through my cofactor expansion one more time with a different thing, and what I'll do is I'll make it so that it doesn't clash here. I need to also carry my velocity B as just a symbol for a time being. And then I'll do my I again, Xing that out and this out and taking this. 0, omega BC, 4 sine of 30 and nothing, minus J, and the J, I X this one out and this one out, and I take this and move it over. 0, omega BC, 4 cosine 30 and 0, and then I do the useless one, and I'm just doing it to be complete, and that is drop those out and take this over here. 0, 0, 4 cosine 30, 4 sine 30. This one's going to give you nothing, 0 to 0. This one is going to give you this, and you minus that. minus 4 sine 30 mega BC. You notice I expanded my shorthand back out. And then this gets you nothing, and this gets you a minus there. So this is going to be a minus, it's going to be a plus, it's going to be a plus, this is going to be a minus. But I got a minus attached with another minus, gives me back a plus, and that'll be 4 cosine 30, there you go, BC, J, plus, I'm going to go ahead and carry my velocity V right down here, which actually, technically, I guess I should have carried it here. So I'll say it went from here to here and from here to here. Now, I guess it's almost time to go. I'll complete this out next time, but I'll say, let's do a check. This number times that number plus this number times that number. First of all, get a minus sign on this one and a plus sign, plus and plus. So I think I'm okay. I think it drops out. It basically becomes, the dot product becomes 0. So you know what? 48. I can pick up exactly here if you want me to, or if you want me to keep going. What do you? So, because that's the beauty of this thing. I mean, I turn on the tablet, it's right there, exactly where I was. Matter of fact, oh no, I do it up here. I'll go to the top, and I'll say continue on Wednesday. And then it'll show up as a title there. I better put in there dynamics too. Dynamics continue on Wednesday. That way I can find it in the list of all this junk. Alright, another day and another 25 cents. I don't earn $1. So is this, am I doing okay? I mean, I guess it's too late to figure out if I'm not.